In this video, we're going to take a look at a Leetcode problem called minimum size subarray sum. So we're given a positive integer array and a positive target integer element, and we're trying to find the minimum length of a contiguous subarray that has a sum that's greater than or equal to the target. So if there's no subarray that has a sum that's greater than or equal to the target, we're going to return 0 instead. So here you can see we have an example of integer array. We want to find a subarray, contiguous subarray that has a sum that's bigger than or equal to the target. And we want to find a subarray that has a smallest length. So in this case, we're going to have subarray 4 and 3. We could choose 1 plus 2 plus 4, which give us a sum that's bigger than or equal to 7, but the size is, in this case, is 3. And for this subarray, the size is 2. So we want to choose the smallest subarray. And the goal, the output is basically we want to return the minimum length. Okay. And now here you can see we have another example where we have a positive integer array and positive target. In this case, the minimum length is going to be 1 because we can have one element in the subarray, and in this case, we're just returning 1. So here you can see we have another example where we have an integer array, a bunch of 1s, and in this case, we're just returning 0 because in this case, we cannot find a subarray that has a sum that's bigger than or equal to 11. Right, or the target. So in this case, we are going to return 0, just like what the question mentioned. And the thing about contiguous subarrays is that we want to have all the elements in the array. We basically want to find a contiguous subarray. And contiguous subarray basically means that a subarray that all the elements in the subarray are right next to each other, right? So to solve this problem, one way we can do this is we can use a brute force approach. And we're going to iterate each and every single element, and for each element we're going to try to find a combination or find a contiguous subarray that has a sum that is bigger than or equal to the target. And from that, we're going to continue to find that. We're going to get, at the end, we're going to get a size, a minimum length. And now this will give us a time complexity range from n squared to n to the power 3. So I'm not getting into that. So what we can do instead is we can be able to solve this problem in a linear time complexity using sliding window technique. So the idea is pretty simple. We're going to use sliding window technique to solve this problem. And basically, we're going to have a left pointer and the right pointer. The right pointer basically is the pointer that expands our window, and the left pointer is there to try to contract our window. So the idea of sliding window is pretty simple. We're trying to have a window, and if we're basically moving our right pointers to expand our window if we don't satisfy our condition, right? If we do satisfy our condition, we're going to start to contract our window so that we can be able to bring the time complexity down to a linear. Now, what is our condition? Our condition is that we want to find a subarray that has a sum that's greater than or equal to the target. So in that case, currently we have a window that has only element 2 in it. So our currently sum is 2. And the minimum, right, in this case is going to be integer.max, right? So we have infinity, right? So in this case, so far we have a min that's equal to max because so far we haven't met the condition. We need to met the condition to be able to update our minimum subarray length, right? So we're going to first move our right pointer 1 to the right to expand our window because our current condition doesn't satisfy. So now we have 5, and now we're going to expand it again because 5 is less than 7. So now we have 6. And now we can continue to expand again. Now we have 8, right? So 8 satisfies the condition because 8 is bigger than or equal to the target. And now we're going to update our length, minimum subarray length. Now we have 4 items in our contiguous subarray. So we're going to update that for our minimum variable. Now we're going to start contracting our window because in this case we want to find the smallest element, right? So to contract our window, we're going to move the left pointer 1 to the right. And we want to make sure we update our current sum as well. So in this case, we remove 2. In this case, we have 8 minus 2 is 6. So 6 is less than 7. So we're going to focus on expanding our window. So now we have 4. So 4 plus 6, now we have 10. So 10 is going to be our new sum. And in this case, we have a size of 4. And in this case, we satisfy the condition. So we just update our minimum subarray length to 4. So then we're going to contract our window because now we've met a condition. So now we have remove 3, so now we have a sum of 7. So the size in this case is 3. And in this case, we're just going to update our size because now the size is 3 is less than 4, so we update that. And then in this case, we have to continue to shrink our window because we met the condition. So now we remove 1 out of sum. Now we have 6. So now we start to not met the condition. So we now have to expand our window. So now we have added 3 onto our sum. So now we have 9. So 2 plus 4 plus 3, we have 9. And now in this case, we're going to have met the condition. We're going to update our minimum subarray length. Now we still have 3. And then we're going to start to contract our window again because in this case we met the condition. So we remove 2 out of 9, so now we have 7. So 7 met the condition, but we have found our new length, right? So we're going to update our new contiguous subarray length that's less than the current minimum. So we have 2. What we're going to do is we're going to continue to shrink our window, right? So now we have 3. So in this case we have 3 in our window, so now it doesn't satisfy, so we have to continue to expand. And now our right pointer go out of bounds, so our job is done. So this is pretty much how we're going to solve this using a sliding window technique. And there could also be another case where we have our window, right? Our subarray doesn't really match, cannot find a subarray that has a sum that's bigger than or equal to the target. So in this case, we're just going to return 0. So to solve this problem, first we're going to define our pointers. Because the constraint says that the array is going to have a length that's bigger than or equal to 0, so in this case we don't have to do the base check. So we're going to first define the pointers. So once we define the pointers, right, our left and right, like where it starts, where it ends for our window, then we're going to focus on defining our minimum, right, our current minimum subarray length, as well as the current sum, right? So then we're going to focus on perform sliding window to find the minimum subarray length. Okay, so in this case, we're going to define our pointers, which is left is equal to 0, the right is equal to 0 to start, and our current minimum in this case is going to equal to integer.max value, so that when we find in this case, when we met the condition, right? Once we met the condition, we can be able to update our minimum, right? So in this case, we will compare the current contiguous subarray size with the current minimum. See who has the smallest element, right? Who has the smallest integer value. And then we have our sum, which is going to equal to 0 initially, right? And then in this case, we have integer n is going to be nums.length. Okay, so now we're going to have perform our sliding window technique. So we're going to say while the right pointer is less than n, we're going to perform our sliding window. Now at the end, we want to make sure we have the correct answer. So in this case, if min is still equal to integer.max value, then we're going to return 0 because we cannot find it. Otherwise, we will just return minimum. So first, what we're going to do is we're going to first add the element that the right pointer, add the current element. So add the current element that the right pointer is pointing to onto our sum, right, onto our window. Then we're going to see if we met the condition, we're going to start to contract. So contract our window, right? So those are the two things. So in this case, we have our sum plus equal to nums at right. So we're adding our current element onto our sum, our window. Then we're going to see if we met the condition, right? So in this case, if our sum is, in this case, if our target is less than or equal to the sum, right? So in this case, if sum is bigger than or equal to target, we're going to shrink our window, right? But first we want to make sure we update our minimum subarray length. So in this case, we're going to have minimum is going to equal to math.min, either the current element value, or we have getting our current size of the contiguous subarray, which is going to be, this is basically the size of the how many elements we have in the subarray. So then we're going to remove, right, because we now have to contract our window, so we're going to say sum minus equal to nums at left, right? And now left moving one to the right, because we are moving, we're basically move the left pointer one to the right, so we want to make sure we update our sum. Now at the end, we want to make sure after we contract our window, we want to move the right pointer one to the right, so that we can be for the next iteration we're going to add the current element, right? So let's try to see what it looks like after we run the code. Okay, so now let's try to submit. And here you can see this is how we solve this minimum size subarray sum in a linear time complexity. And the space complexity in this case is going to be constant.